Hi guys, so I hope you remember what we learned about families of functions in chapter 2 because we're really going to be using this again in chapter 4. We're going to apply our knowledge to quadratic functions and their transformations. So for objectives, we're going to be answering the question, how does our understanding of families of functions help us understand quadratic functions? So we're going to identify transformations of quadratic functions and then graph them on a coordinate grid. So we have a few vocabulary words. A parabola is the graph of a quadratic function, which you can write in the form f of x equals ax squared plus bx plus c, where a cannot equal 0. If a equals 0, then there's no x squared, so then it's just a line. And if you don't remember, a parabola is that U-shaped thing. The vertex form is f of x equals a times the quantity x minus h squared plus k. So again, you can see we're using that a, h, and k again, just like we did when we talked about absolute values. The axis of symmetry is a line that divides the parabola into two mirror images. So again, it's that vertical line that mirror images. We talked about it when we did absolute values again. And the vertex of the parabola is hk, and that's either the minimum or the maximum of our U-shape. And if a is greater than 0, the parabola opens upward, and your y value is a minimum. But if a is less than 0, that means it's a negative number, then reflections come into play, and it's going to open downward, and we're going to have a maximum value for a vertex. So here's a parent function of our quadratic. Our parent function is f of x equals x squared. Our axis of symmetry is x equals 0. Our vertex is at 0, 0, and you can see it makes that nice U shape. So for graphing, what is the graph of f of x equals 1/2 x squared? What we're going to do is we're going to start by plotting the vertex. Since we're not adding or subtracting anything, you can always assume that our vertex is 0, 0. So then we're going to plot our vertex, draw our axis of symmetry, and then we're going to find and plot 2 points on one side of the axis and then mirror image it across to the other side. I'm going to pick multiples of 2 when I do it, just so that we get nice numbers. Plot the corresponding points on the other side of the axis of symmetry and then sketch the curve. So I'm going to go ahead and sketch this out for you. Okay, so since it's positive, we know it's going to open up. So here's my vertex 0, 0. I'm going to go ahead and make my axis of symmetry. I'm just going to make it in red so that you can see it's here. And this is the line x equals 0. Vertex is the point 0, 0. Okay, now I need to pick 2 other points, and I'm going to pick positive points just to be easy. So if x is 2 and 4, so 1/2 of 2 squared. 2 squared is 4, half of 4 is 2. So I know I have the point 2, 2. And I can also reflect this across on the other side. Okay, 1/2 of 4 squared. 4 squared is 16, half of 16 is 8. So, 1, 2, 3, 4, 5, 6, 7, 8. So here I have a point over here. Have a point over here. Now remember, parabolas are U-shapes, so when I connect the dots, I make a nice smooth curve. So here is my graph for my quadratic. Okay, so I want you to go ahead and graph this one, and then I want you to make a conjecture about what that value does in front of the x squared. You can also graph both of these on your graphing calculator. F of x is the same as y. So you can, why don't you just go ahead and do that. I want you to put in y1, y equals, you don't have to do y equals x squared. In y2, I want you to do what we just did, 1/2 x squared. And then in y3, do negative 1/3. X squared, and then graph all of them at the same time and then see what happens and then make a conjecture that you're going to talk about with your partner. Okay, so we have reflection, stretch, and compression. So if we have, this is our parent function, if we have a reflection, a negative is going to flip it upside down. I hope you figured that out when you did the negative 1/3. A stretch is going to make it narrower, and a compression is going to make it wider. So anything greater than 1 is a stretch, it makes it narrower. Anything between 0 and 1 is a compression, makes it wider. Okay, now we're going to talk about graphing translations. How is each graph translated from f of x equals x squared? If you remember what we talked about when we did families of functions, this should come pretty easily to you. So go ahead and put this one into your graphing calculator, y equals x squared minus 5. And then I want you to compare and look what happened from the parent function. Hopefully you found that it was translated down 5 units, and we learned that when something is added or subtracted on the end from a parent function, it moves it up and down. And this one, h of x equals parentheses x minus 4 quantity squared. Go ahead and put that one into your graphing calculator and see what happens. You should have found that this moves it right 4 units. And you remember when we talked about things being inside the absolute values, they move right and left, and it's the opposite of what it did before. So what do you think this one is going to do? Move it up 3. Or this one should move it left 1. So hopefully you remember those things about our parent functions. So for this one, y equals 3 times the quantity x minus 4 squared minus 2. What is the vertex, the axis of symmetry, the minimum or maximum value, and the domain and range? So for this one, we're going to look at our vertex form is y equals a x minus h squared plus k. Do you remember that hk is always our vertex? Well, in this case, hk would be 4, negative 2. So it's moved right 4 and then down 2 for our vertex. So that's the first question. The axis of symmetry is just the line that goes through your x value. So it's the line x equals 4. Is it a minimum or a maximum value? For that, you have to look at your a. If a is positive, it goes up. A is negative, it goes down. So if this a is 3, that's positive, so it opens up. So it's going to be a minimum value. And the domain and range, and that's just any values or any restrictions that are given for your graph. So here we have 4, negative 2 is our vertex. Do we have any restrictions on what our x values can be? Remember, x values are our horizontal values, so from left and right. Will this graph continue to go forever and ever in directions left and right? Yes, so our domain is all real numbers. But what about our range? For our range, that's values that are vertical. Do we have restrictions on our y values? Yes, we do, because it can never go below this line right here. So what is the smallest y value we can have? Negative 2. And does it include negative 2? Yes. So y has to be greater than or equal to negative 2. So there's our domain, our range, our vertex, our axis of symmetry, all those great things. Okay, so why don't you go ahead and do this one, and you're going to compare it with your partner. This will be your, this and your conjecture from your what does the A do is going to be your lesson check for this lesson. So go ahead and state your vertex, axis of symmetry, whether it's a minimum or maximum, and then the domain and range. Alright, so when we talk about translations, H is what moves it up and down. Or left and right, I'm sorry. And then our vertical is the K. So K is going to be what moves our parabola up and down. And you can have a combination of the two as well. So you can have horizontal and vertical. That includes both H and K values. So using our vertex form, we're going to go ahead and graph this. So we're going to take it apart a little bit of one piece at a time. So first, let's look at what information in here is important. Well, we have a -2, so our A is -2. So we should know that it's opening upside down, so we know it opens this way, and we should know that it is narrow. We also have this -1 and the 3. So our HK, our vertex, is the opposite, +1 and +3. Okay, from this information, can we graph a parabola? Yes, because we also know that x equals 1 is our axis of symmetry. So I'm going to go ahead and just do a quick sketch here. Alright, so 1, 3 is right here. And here's our line, x equals 1, that we're going to reflect across. We know it should open down, so let's pick a point. So 2, let's do 0. I like 0. So if x is 0, that means we have 0 minus 1, which is, let me just do this, -2 times 0 minus 1 squared plus 3. 0 minus 1 is -1, -1 squared is 1. 1 times -2 is -2, plus 3 is 1. So I know I also have the point 0, 1. And I can also reflect that across to the other side right there. And now let's go ahead and do 3. So if x is 3, we're trying to find our y value. -2 times 3 minus 1 squared plus 3. 3 minus 1 squared is 3 minus 1 is 2. 2 squared is 4. 4 times -2 is -8, and -8 plus 3 is -5. So I know I have 3, -5 as a point. And I can also reflect that across on the other side. So 2 over, and make a curve. There we go. We made our parabola. Easy peasy. Okay, and then looking at this, can you tell me which one of these multiple choice represents the transformation from our parent function y equals x squared to this function y equals -2 times x plus 1 squared plus 3? Well, we know it's stretched by a factor of 2, and it's also reflected because it's negative. The positive 1 moves it left 1, and the positive 3 moves it up 3. So which one of those is correct? The correct answer would be D. Okay, and we can also use this to solve problems. So for this one, here we have a picture of a dolphin, and they kind of make a parabolic jump when they jump out of the water. Has everyone ever seen a dolphin jump out of the water before? It's pretty awesome. So let's go ahead and see if we can write a formula for this. So if we're going to use our vertex form, that's y equals a x minus h squared plus k. Now by looking at this picture, we can see that 3, 7 is our vertex. So we can go ahead and just plug that one in right away. So y equals a times x minus 3 squared plus 7. Okay, now we don't know what our a is, but we could find it by picking another point on this line somewhere. So somewhere where the graph crosses, it looks like 9, 4 is another point where it crosses. So I'm going to go ahead and plug in 9 for x and 4 for y, and I'm going to solve this and find out what my a is. Okay, so 9 minus 3 is 3 squared plus 7. Okay, I'm going to subtract 7 from both sides. So I have -3 equals 9a. Divide by 9. A equals -1/3. So I'm going to go ahead and plug that in to my equation right there, and we made a formula. Y equals -1/3 x minus 3 squared plus 7 models that parabolic jump of the dolphin.